Hey everyone, welcome to section 10.6. This is Nick Jacobs, your intermediate algebra instructor here at Yavapai College. So let's get started. We have quite a bit to do for this section, and that's kind of why I split this chapter up into two parts, really, 10.1 through 10.4, and then 10.6 and 10.7. So this lecture is going to be a little bit longer. So again, as always, feel free to kind of skip through the parts that you find useful. So let's go ahead, and today we're talking about equations involving radical expressions. So we're going to solve radical equations. We're going to derive and apply the distance formula, which maybe you've seen before. And then we're going to solve equations in the form where they have a power and an equal sign. So some of them will have radicals, and we'll kind of undo the radical, but then some of them will have a power, and we're going to undo the power. So there's kind of a power rule for solving equations. Now this is a lot of words, but essentially what we're doing is we're trying to eliminate the radical, okay? And this will make more sense once we go through some examples. So I'm not going to read through this, but you can feel free to do that yourself. So again, the best way to do this really is to go through some examples. So basically, we're going to undo the radical in these questions. Okay, we need to solve for x. So the equation here is 4 times root 2x plus 1 equals 12. Okay, and we have to solve for x. And then what we're going to do with these is we have to check the solution. And that's because sometimes when you're solving these radicals, you can have two different solutions, and one of them might not work. And I'll talk about that here in a second, but this one will only have one solution. But the key to these, everybody, is we need to get the radical alone first, okay? So get a radical alone on one side. And that's our first step. So we have to do that first. So right now we have this root 2x plus 1 here is our radical expression inside the radical. We need to do something with this 4 to get this radical alone. And it's very simple, right? This is being multiplied 4 times this entire radical. All I do is divide the 4 on both sides. And that can be kind of counterintuitive sometimes when we're solving equations, because we've kind of been taught that we're not going to divide or multiply until the very end. But sometimes, you know, if you're trying to, like, let's say you have fractions and you're trying to get rid of the bottom of the fraction, we have to multiply first in that radical. And we might see, or not in the radical, but in that equation. And we might see that later as well. But now that we have kind of isolated the radical, okay, and that's kind of our first step, okay? So we're going to isolate the radical, okay? And then this is where we're at. Now what we're going to do from here is we're trying to kind of undo it. So how do we undo this square root? Well, we do the opposite of a square root, which is squaring. So I'm going to take I'm going to square this guy, okay? And again, as in any equation, what you do to one side, you do to the other. And I always like to put these in a parentheses, okay? That just emphasizes we're squaring this entire thing. If it was more than just a 3, we would have to, if it was 3x plus 1 or something, we would have to square 3x plus 1, and then we would have to multiply all that out. But let's go ahead and square this. So when I square a square root, I just have what's left on the inside of the square root. We've talked about that before. So I just have 2x plus 1 left on the left side. And then 3 squared is 9, 3 times 3. And then here it's just a very simple equation. I'm going to subtract 1. So 9 minus 1 is 8. And then divide by 2. So x equals 8. Now, what I want us to do, sorry, I have these words here, but we're going to check this, okay? So how do we check? Just like any equation, right? We substitute it back into the original equation. So we got 4. 4 was our answer. So we have 4 times square root of 2 times our answer of 4. So we substitute right here, plus 1. And again, what we're asking is, does that equal 12? Okay, so does the left side equal the right side? And we're going to find out. So we have 4 times square root of 2 times 4 is 8 plus 1. Maybe I don't need to do all these steps here. You guys should be able to do this by now. But we have 4 times the square root of 9 is 3. So we have 4 times 3. And does that equal 12? Well, yes, 12 is equal to 12. Okay, so that checks. So what does it mean when it checks? Okay, this means that x, because it checks, x equals 4 is the solution. Okay, some people get confused with the checks, and this is just kind of a review, but some people get confused and say, oh, 12 is the solution. No, it's not. It's just what, it's what we got when we substituted back in. One side is equal to the other, but really x equals 4 is the solution. All right, so I do have some steps here for solving a radical equation like we just did. Okay, and again, the main thing here is to isolate the radical term on one side. Okay, we're going to apply this power rule by basically canceling out either the square root, the cube root, whatever it is. Okay, so we're going to raise each side of the equation to the power equal to the index on the isolated radical term. So I squared the last one because really our index of a square root is 2, right? So I square it with a 2. Solve the equation. So if it still contains a radical, you're going to repeat the steps 1 and 2. And that's important. When I will do an example of that where we actually have to not square it once, but we actually have to square it twice. And then we're going to check for what we call, and what I had mentioned before, but I didn't define it. We're going to check for extraneous solutions. Okay. And that is, we do that by substituting each result, okay, or one result into the given equation. Okay. So I will go through an example of that. It doesn't make a whole lot of sense right now unless I do it. But so let's solve this radical equation. So we have the square root of 6 minus x, that's inside the radical, minus 3 equals 1. Now, again, the first step is to isolate the radical term. So I'm just going to kind of click through. I have some steps here. So we add the 3 to both sides of the equation, right? So we have now square root of 6 minus x equals 4 when we add 3. And then again, our next step is to do this, what we call the power rule here, kind of. So we're going to square each side because we have a square root, right? Our index right here, really, our imaginary index is 2 there. So we're going to square each side. And then we're going to solve the resulting equation, okay? So when we square this, we're going to get 6 minus x, right? You square a square root, you just get what's left on the inside. And then 4 squared is 16. And then I just continue, I'm going to solve this. So I subtract 6. These can get a little confusing for people sometimes. But when I subtract 6, I still have a negative x. 6 goes away over here. 16 minus 6 is 10. And then I divide by -1, which just changes the 10 to a -10. And then we still have to check that answer. I think I have that on the next slide. I'm just checking. And I do. So we're going to check if -10 is in fact the solution. So here's our original equation. So we substitute it back into the given equation, or what we originally had. Okay. So we had gotten -10. So I'm going to say 6 minus, now this is, don't get this messed up. Okay, 6 minus a -10, right? Because I'm substituting in for x. This subtraction symbol stays. And then -3 on the outside of the radical equals 1. And it's important to, keep the subtracting 3 on the outside. So I'm going to do the same thing that I did before. Okay, so are these two sides of the equation equal? Okay, well, let's move this around. Actually, I'm not solving this. I'm sorry. I'm not solving. I'm just simplifying on each side. So don't get that confused. Sometimes people, when they check, they try and move things around, but we're not solving for x, we're just simplifying. So 6 minus a negative 10 is positive 16. Minus 3, is that equal to 1? Well, the square root of 16 is 4. And 4 minus 3 is in fact 1. So yes, this checks. So I'm going to write it out again, just to emphasize. This checks. So x equals negative 10 is the solution. Okay. All right, let's do another one. Now we can also solve these graphically. Okay, so if I would have graphed this thing, actually, yeah, actually we could graph these. Okay. Oh, hold on one second. Actually, I'm thinking of when we have an x on both sides. So when we have an x on both sides, we can check it graphically. Okay. So let's try to solve this. Just like we normally would here. So I'm going to give what we call our symbolic solution. So let's go through the steps here. And then again, we will have to go ahead and check. So this one, the radical is already isolated, right? So I don't have anything else on one side. I have a radical on one side and I have other stuff on the other side. Okay, so I can just go ahead and get right into the steps. Now this one is another square root. So I'm going to take this guy and I'm going to square both sides, and I won't rewrite it here. I'm going to try to save some room, and I'll just go ahead and square right away. So I have 3x minus 2 after I square the square root. And then what is x minus 2 squared? Well, x minus 2 squared is, I'll tell you what it's not equal to. It's not equal to x squared minus 4, right? It's not equal to that. So some people make that mistake. What you have to do is you have to multiply it out. Okay, so you have to, x minus 2 squared is 2 x minus 2's, right? And then we have to FOIL it. So we get x squared minus 2x plus 4, which is x squared minus 4x plus 4. So let's bring that down. And now we're solving again for x. Okay, so I have an x squared over here. I'm just going to move these guys to this side. Okay, so again, I'm going to save some room. We're subtracting 3x from both sides. So negative 4x minus 3x is negative 7x. And then we add 2. So our like term is 4. So 4 plus 2 is 6. So I have 0 equals x squared minus 7x plus 6. And this guy is factorable. Remember, we wanted factors of 6 that add to negative 7, which would be negative 1 and negative 6. So I have x minus 1 and x minus 6. And remember our zero product property. What we do is we take each of those and we set them equal to 0. So this is kind of a review of chapter 8. So then we get x equals 1 or x equals 6. So so it's either 1 or it's 6 or both. Okay, now we might have one of these might be extraneous. Okay, so let's check the well, let's do the 6 first. Okay, so let's check the 6. So we're going to go ahead and substitute 6 in for x. And there's a reason why I'm checking the 6 first. So we get this guy. 3 times 6 is 18. 18 minus 2 is 16. 6 minus 2 is 4. Square root of 16 is 4. Okay, so x equals 6 is definitely a solution. Now let's check the 1. Okay, so we're checking, so we check the 6. And here we're going to check the 1. So 3 times 1 minus 2, and then 1 minus 2. So 3 times 1 is 1, or sorry, 3 times 1 is 3, minus 2 is 1. So I have the square root of 1. Does that equal 1 minus 2, which is negative 1? Well, no, right? Let me put that question mark in there. 1 is not equal to negative 1. So 1 is an extraneous solution. So x equals 6 is a solution, but x equals 1 is an extraneous solution. Okay, and what does that mean? That means that when we solve this equation, we got 1 as one of our solutions. Okay, but when we checked it, it didn't work. Okay, and there is a reason for that. Okay, and I'm going to show you that kind of with a graph, so it can kind of make a little bit more sense for us. Okay, but it is also possible that when we do these equations, that there is no solution. Okay, or there could be 2 solutions. Okay, or possibly 3. Okay, I can't think of an example off the top of my head that would have 3. But when we check it graphically, this is going to make a little bit more sense. So I'm going to stop sharing here just for a second. And I think I have Desmos open. So what we do here is our equation was the square root of 3x minus 2 equals x minus 2. So I have 3x minus 2. So that looks like that. Okay. And then the other equation was x minus 2. Oops, x minus 2. And we see here that we got 6 as one of our solutions. And that is where these graphs intersect. Okay. So we can see here the point here is 6, 4. Now you don't have to know that point, but when equations have a solution, they're going to intersect. Okay, these lines are going to intersect. And so we had got that 1 was an extraneous solution. Okay, and you can kind of see here that if this red line was extended, it kind of looks like a parabola that's been turned. If this parabola kept going, it might go through right here. Okay, it might go through right here at 1, -1. Okay, but it doesn't, it stops. Okay, and it stops, and we had kind of learned how to graph these, right? That the range for this, right, is only from 0 to infinity. Okay, it doesn't go into the negatives because we can't have a negative square root. Okay, so this cannot extend down here and go to this x point, this x point of 1, okay, and the y point of -1. So that's why 1 is going to be extraneous in this case. All right. Oh no, I was not sharing that entire time. I'm sorry. Let me go to Desmos. Okay, let me kind of redo that here. Maybe I'll edit that out. So this is what I was talking about. We have the red line is the square root of 3x minus 2, and the blue line is x minus 2. And those intersected at the point 6, 4. And any time where lines intersect, that's going to be the solution of that equation, or the lines, okay? But we can see here that this red line would have kept going down if it was a full parabola. It probably would have kind of done something like this, right? But it doesn't, because the range is only 0 to infinity here, because we can't have a negative square root. So this could not have went down here and crossed at the point 1, -1. So 1 is an extraneous solution. All right. Let me stop that. Let me go back to the PowerPoint. Sorry about that, that I wasn't sharing. So, or sharing my screen there in that case. All right, so hopefully I am now sharing my PowerPoint. And again, I graphed it on Desmos, but I also showed it right here. So maybe if you had printed off your notes or something, you were kind of looking at that. Okay. All right, let's do another example. Okay, and this one just has a little bit more work involved. But we look at this and we have the square root of 4x minus 3 equals square root of x minus 3. And you might be tempted to, oh, okay, I need to plus this 3 to the other side. You could do that, okay, and you'd still get the right answer when you square both sides. But I already have a square root that is alone on one side, so there's no need to move anything around. I'm just going to go ahead right away, and I'm going to square both sides. Now, the key thing is when you square it, you have to square everything, okay? So this guy doesn't just cancel out, right? I have to basically write this twice. So I have the square root of 4x minus 3 times the square root of 4x minus 3. And it doesn't cancel out because this one is not under a square root. If this was all under a square root, then yes, we would have 4x minus 3 left over. But I don't, so I have to write it out and then eventually FOIL here in the next step. But the square root of x minus 3 squared is, in fact, just x minus 3. So let's go ahead and FOIL this. I have the square root of 4x times the square root of 4x. So really, I have the square root of 4x squared minus 3 times the square root of 4x, right? And then minus another 3 times the square root of 4x. And then negative 3 is positive 9. Okay, so let's see if we can simplify this. The square root of 4x squared is just 4x. These guys are like terms, so let's put those together. I just basically I have a minus 3 to minus 3, which gives me negative 6. The square root of 4x acts as like your variable here, and then you just add the coefficients. And then plus 9 equals x minus 3. Now, you can see here that we still have a square root in this. So I'm going to keep simplifying, but this is an example where we are going to have to square this twice. Okay, so it's a little bit more work than what we've been doing. Well, let's try to get this square root here on just alone on the left side. So I'm going to subtract this 4x. I will show some of these steps here because it can get a little confusing. And then I'm going to subtract the 9 over here. So I have negative 6 times the square root of 4x equals negative 3x minus 12. And then at this point, what we can do is we can actually divide. Let me see here. Where am I at? I want to make sure that oh, okay. This is a minus 6. So I could keep going like this. I could divide by negative 6, but then I would be working with fractions and I don't want to do that. So I'm actually going to, at this point, since I don't have any addition or subtraction between these, I can go ahead and square this again. Okay. So at this point right here, we're going to square again right here. And what that gives me here is negative 6 times the square root of 4x squared. That's just going to be positive 36 times 4x because I square both of these things, right? I square negative 6. That gives me a 36. I square the square root of 4x, and that just gives me 4x left over. But here, when I square this guy, I have to write all of this out and then FOIL it. So let's FOIL this. First of all, 36 times 4x. 36 times 4, I think I wrote that down. That's 144. And then negative 3x times negative 3x is positive 9x squared. Negative 3x times negative 12 is 36x. Negative 12 times negative 3x is another 36x. Negative 12 and negative 12 is 144. So now let's get this simplified down a little bit more. add the 36's, we get 72x plus 144. Subtract 144x to the right side. So 72x minus 144x is negative 72x. And now I can take this guy and I think I can factor this. And you know what? This is a perfect square trinomial. How do I know that? Because this 9x squared is a perfect square, right? 9 is a perfect square, x squared is a perfect square, and 144 is a perfect square. So what is the perfect square of 9x squared? Well, if I square root that, I'm going to get 3x, right? So let's go up here. And then if I square root 144, I'm going to get 12. So I have 3x. And then since this is a minus, it's going to be a minus 12. So 3x minus 12 times 3x minus 12. If you don't believe me, if you need a little bit more practice on the factoring from I think it was a couple chapters ago, you can definitely go ahead and factor this yourself. You can do it the long way, right? Where we did the 9 times 144, got a number, and then we split the middle term. If that way works for you, you can definitely do that. Or you can recognize that this is a perfect square trinomial, as we also talked about. So this one, right, I could write as 3x minus 12 squared, and I actually want to do that. And the reason being is because at this point, I'm still trying to solve for x. I need to square root. I need to square root both sides. Well, the square root of 0 is 0, and I square root it to get rid of the squared. So I undo a square, I square root. So I have 3x minus 12, add 12 to both sides. So I have 12 equals 3x, and then divide by 3, and I get x equals 4. And then again, you do have to check this, and I think, let me check my notes. Actually, I did not give myself room here to check. So I'm going to check all the way up here. So let's check. Let's substitute the 4 into the original equation. So 4 times, that's a square, sorry. If you've been watching my lectures, you know that I mess this up or somehow the pen messes up and it gives us that little line above the 4. There we go. So I square root of 4 times 4 minus 3 equals the square root of 4 minus 3, or does that equal it, right? Whoops. So does this equal it? I can't write a question mark up there because it's in the way of my screen sharing. But square root of 4 times 4 is square root of 16. Square root of 16 is 4. And 4 minus 3, in fact, does equal 1. So 4 minus 3 is 1. Square root of 1 is 1. 4 minus 3 equals 1. So this does check. So x equals 4, or 4 equals x, however you want to say it, is the solution. All right, now let's do one. We haven't done one of these yet, but where we have a cube, okay, or a cube root. So same kind of process, right? It's already isolated, so I don't have to worry about that. Okay. So step 2 is using that power rule. So since it's cubed, I'm going to go ahead and cube each side, and then I'm going to solve the resulting equation. So let's go ahead and do that. Let's just do it right here. We have this guy. We can cube this right away. And what that does when you cube a cube, or sorry, when you cube a cube root, again, we just get what's on the inside. And then, so 2x plus 6, 4 cubed, 4 times 4 times 4 is 64. You keep solving it, subtracting 6 here, we get 64 minus 6 is 58. And then divide by 2, 58 divided by 2 is 29. So we have to check here if 29 is in fact the solution. So let's go ahead and take our original equation and plug 29 in for x. Oops, this should all be under the cube root. So simplifying, 2 times 29 is 58. 58 plus, well, let me just write that. 58 plus 6 And then 50 plus 6 is 64. And the cube root of 64 is in fact 4. So it checks. So x equals 29 is the solution. Okay. Awesome. Now, sometimes you have to solve these graphically, okay? And if we tried to solve this by hand, we could, but we would just get really weird numbers. Do we get decimal numbers? So sometimes the best thing to do is to solve graphically. So let's take this. We have x raised to the 3/4 power equals 4 minus x squared. Let's solve this graphically. So I'm going to stop the share here. I'm going to open up Desmos. And this time I am going to try and remember here to share my Desmos screen. There we go. Again, I said this lecture was a little longer, so, but x to the 3/4 looks like that. And then 4 minus x squared. And we have a solution there. And that solution, kind of zoom in, is where they intersect. And it's right there. So I got 1.604. And for my x value, so that would be the solution, okay, where x is 1.604 and y is 1.426. Let me write those down because when I go back, I just want to make sure I still have this. Now I have Desmos rounding out to 3 decimals here. You can actually change the settings. I'm not sure off the top of my head where it is, but you can change the settings. Maybe it's right here to round it to more decimal places. You guys can kind of play around with that. But again, you could round this out to 10 decimals or 20 decimals if you want it to. Okay, just find that setting somewhere in Desmos and it'll do that for you. So let me go ahead and I might have to close all this out. Gotta see. Sometimes when this happens, I lose everything. Okay. Let's see if I can get back into Zoom now. There we go. Okay, so I'm back into Zoom. I'm going to go back into my PowerPoint. And I should be, okay, so hopefully, I think you guys, oops. I'm going to need to open that back up. I'm sorry, I'm having technical difficulties here. All right, where is my Zoom? Okay. Here we go. All right, so you should be seeing my PowerPoint now. And so again, we said for this one, we go back in blue here. We know that x equals about, okay, this is about 1.604 would be the solution for that. And the y value, by the way, for that is 1.426, okay, about, all right. You don't have to worry about the y value again, but it is good to know that it's where these two lines would intersect. All right, let's do another example. This one is kind of a geometry type question. So we have a 6-foot ladder is placed against the garage with a base 3 feet from the building. How high above the ground is the top of the ladder? So if we kind of draw this out, and even if I was in person with a nice whiteboard or something like that to draw on, my picture really would not be much better. Trust me. But we have this garage. Okay, we have a 6-foot ladder. It's kind of going down like so. Okay, here's the ladder. It's leaning up against the garage. Maybe they're fixing the garage door outside or something. I don't know. But we have this. This is 6 feet. And then its base is 3 feet from the garage building. Okay, so the base here is 3 feet. And in geometry, well, hopefully the garage is forming a 90-degree angle with the ground. And it does. And then we just need to find this guy. Okay, so we need to find how high above the ground is the top of the ladder. So we need to find this distance right here. We can call it X or something. Okay. And if you remember from geometry, we had this old Pythagorean theorem, right? It was a squared plus b squared equals c squared. And we said that in a right triangle, okay, the sides are a and b, and the hypotenuse is c, okay? So in this case, what I would do here is I would say this is x squared plus 3 squared is equal to 6 squared. And again, your hypotenuse is always opposite the right angle, the 90-degree angle. Okay, and your sides, and if you square them, they add together to equal the square of the other side. So let's go ahead and square all those things. So we have x squared plus 9 equals 6 squared is 36. Let's subtract the 9 to get 27, and then take the square root. Okay, so you have to square root both sides in the end. So then x equals the square root of 27, or we can break this up. Remember, we're looking for pairs. We have 2 3s, I can take that out, and I have 1 left over on the outside. So, or 3 square root of 3. And if you do those on your calculator, you're going to get about 5.2, and it's feet. Okay, so the ladder, whoops, I could say this ladder. Let me actually erase this. Okay, I could say the ladder is approximately 5.2 feet above the ground. Okay, well, you guys kind of know what I'm saying, that the top of the ladder, the top of the ladder is approximately 5.2 feet above the ground. There we go. Okay, so that's how you would solve something like that if you had that on your homework or something. Okay, you have to use the Pythagorean theorem. Okay, and sometimes it might, I might give you, the hypotenuse on the side, and you have to solve for the side. Sometimes I might give you the 2 sides, and you have to solve for the hypotenuse. Either way, here's an example you can kind of go off of. And again, if you had to solve for the hypotenuse, it would be a little bit different, of course. Now, we're going to get into something called the distance formula here. So this is when, you could have 2 points, let's say on a graph in the XY plane, and you could find the distance between those 2 points using this formula. And it goes like this. It's D, and D stands for distance. Okay. The distance is equal to the square root of the x value of one of the points minus the other x value squared, plus the y value of one of the points minus the y value of the other point squared. And then we square root all that. So let's do an example. So if I had these 2 points on a graph, okay, so for example, here's a graph. Okay, if I have -1, 2, that point's going to be somewhere over there. And then 6, 3, 4, 5, 6, 6, 4 is going to be somewhere right there. I could use this formula to find the exact distance between these 2 points. Okay, that's what it means here. So let's go ahead and do that. So I already have kind of copied the formula down. Now the important thing is we have to label these points first. So this is an X point, this is a Y point. Let's label this as my first X point, this is my first Y point. So we do X sub 1, Y sub 1. Okay, and then x sub 2, y sub 2. So these are my second x and y points. And then all we do is we take that and we substitute those in. So I have my second x point was 6 minus, be careful, -1, square that. So you need a parentheses around the -1 and then close the parentheses off. And then our second y point was 4. Our first y point was 2, and square that. So now this is 6 minus -1, that is 7. Okay, and I have to square that, plus 4 minus 2 is 2. So let's go ahead and do 7 squared, 49. 2 squared is 4. 49 plus 4 is 53. And that is about, so the distance between those is about, if you square root that on your calculator, you're going to get about 7.28. So about, those are squiggly lines, 7.28 approximate. And that's the distance formula. So I'll try to kind of wrap this up. Our next thing here is we're going to be undoing the roots. Okay, so before we kind of had to, or sorry, we're going to undo a power. So before we undid the root, now we're going to undo powers. Okay, and there is a special rule here that if your index, okay, or your power is odd, okay, so if your power is odd, then you don't have, basically you don't have to worry about it. I'll show you an example. But if it's even, if n is even, then we have to use this absolute value. Okay. So I'll kind of show you that. And we had talked about that earlier too in the chapter when we had our absolute values and other things like that. But just note, you have to pay attention. Is the power of the root, is it odd or is the power of the root even? Okay. So I have two examples here. So I have, this one is odd, right? The 3, the power here is odd, and this one is even. And again, we said that we have to worry more about when the power is even. Power is even here, and over here, the power is odd. Okay. So let's undo these. Okay. How do we undo? Click ahead. Whoops. How do I undo a power of 3? Well, I take the cube root of that, right? So I'm going to take the cube root of x cubed. And then I have to do the same thing to both sides. So I take the cube root of -216. So the cube root of x cubed is just x. The cube root of -216 is -6. And when you have an odd power, you don't have to worry about anything else. Okay, you don't have to worry about the absolute value because this -6 can be the only solution here. It's the only value of x that gives us -216. Okay, but if I have a even power, okay, as we learned earlier in the chapter, that you can have two different numbers that give you this answer. Okay, so in this case, when we take this, the square root of x squared, the square root of 17, okay, I need to make this into an absolute value of x because I'm taking the square root of a power that is even. Okay, the power is even and the index here is even. So I have the absolute value of x equals the square root of 17. So we have to break this up. So we need to break it up. We need to break this up, okay, into x equals the square root of 17 or x equals the square root, or sorry, negative square root of 17. Don't put the negative on the inside because we can't have a negative square root, right? So these are our solutions here. We could have the square root of 17 positive or square root or negative square root of 17. Keeps trying to say square root of -17. That would be incorrect. negative square root of 17. Okay, so and then again, you only have to worry about that when the power is even. Let me do another one where the power is even. So this one's just a little bit harder. First of all, again, same kind of steps here when we have the radical. We have to isolate this before we can take the fourth root. Oops, isolate. So late. Isolate the power. Okay, so let's divide by 3. So we have x plus 4 to the 4th equals 48 divided by 3 is 16. Now, we notice that our power is even. Power is even. So again, what does that mean? You're thinking power is even. We're going to need to do the absolute value bars, right? At some point. So let's take the 4th root of x plus 4 and take the 4th root of 16. Now, when I do the absolute values here is when we have, oops, this is to the 4th. When we have your power matching the index. Now I'm going to take the absolute value of this guy, x plus 4. 4th root of 16 is 2. So when I do that here, I have to break this up again, right? So this is when you split it. Okay, so break it up. Oops, break it up. Okay, so when we do that, this is kind of a review. You have one of the equations is the original, and then one of the equations is the same thing that's in the absolute value equal to the negative of the other side. So -2 in this case. And then we solve. So x equals, let's subtract 4. 2 minus 4 is -2. Or subtracting 4 here gives us -6. So our answers are x equals -2 or x equals -6. You could substitute both of those in. They would both work for this answer. Okay, so you could check it. Both of those answers are going to work. All right, we're going to wrap up here with a couple of formula questions where we're not really working with numbers. We're working with some variables here, and we're solving for a given, we're solving for one of the variables in the given formula. So this formula here is the volume, or it's the equation for the volume of a sphere with a radius r. Okay, or radius represented by r in this. So this is the actual formula for the volume of a sphere. What I want to do here is solve for r. Okay, so I have the volume equals 4/3 times pi r cubed. I want to get, what is the radius if we maybe have a volume number or something like that. So I think I copied this down. Let's go ahead and try this. So I had mentioned earlier, now if you have fractions, you want to cancel out the fraction, right? So how do we do that? Well, what I'm going to do here is I'm going to multiply this whole thing by the denominator of 3. Some people would multiply by the reciprocal, maybe 3/4, but then we would still have a fraction. I want to get rid of that fraction. So what I'm doing here is I'm multiplying by this denominator of 3, and I'm going to distribute it in. So distribute it to the v. I have 3 times v. 3 times 4/3 gets rid of the 3. So I have 4 pi r cubed. Okay, now I'm solving for r. Okay, solving for r. This is all being multiplied. Okay, that's a pi. This is all being multiplied. So what I can do here is I can divide off the 4 times pi. And divide off the 4 times pi. So I have 3v over 4 pi equals r cubed. And then at this point, what I want to do, let me just write it up here, is I want to cube root both sides. So I have the cube root of 3v over 4 pi equals the cube root of r cubed. And I want to do that because I'm solving for r. So to isolate, so I'm going to isolate the r. Once I have it isolated, I'm going to cube root it. So I just get r equals the cube root of 3v over 4 pi. Now, these can be a little confusing for people sometimes, but you just have to get used to, if you're solving for r, our whole goal is to isolate r cubed. So all my work up to this point was to isolate the r cubed. After I did that, I'm going to use our power rule, and I'm going to cube root this. So this stuff is in this section because it does have that kind of power rule, right? Of working with we're working with radicals and roots and undoing either of them. This one is actually a problem from your homework, and it asks us to solve for u in this case. So I have t equals the square root of 2u over or divided by pi times h. So I want to isolate, I want to isolate the u. So this one, I have a radical. I'm going to use my power rule and I'm going to square both sides. Okay, that's going to allow the radical to kind of go away here. And that's my first step. So I have to square both sides. So I'd have t squared equals, when I square a square root, I just have what's left over on the inside. And then now again, I'm doing all this work to isolate the u. So here I'm going to multiply everything by pi h. And I'll actually, let me do that in red. That'll look a little better. So I have my denominator of pi h. I'm going to multiply everything by pi h here. Okay, so I have pi, whoops, that should be a pi h, I'm sorry. Pi times h. There we go, that looks a little better. So I have pi times h times t squared, right? When I distribute it on the left and then distribute it over here on the right, it's just going to cancel out that pi h on the bottom. So I have 2u left over on the right side. And then I'm solving for u, so I just go ahead and I take this all divided by 2. So I have pi times h times t squared all over u, or sorry, all over 2 equals 2 divided by 2, that cancels, that equals u. So u equals pi times h times t squared all over 2. And let's see here, that is the end of my slideshow. So let me see, I think I can close this out. And I just want to make sure everything saves. It's going to take a little while. All right, let me go back to Zoom. That is section 10.6. Again, probably going to be our longest lecture of the semester. But again, I did try to split these sections up. So we just have one more section of chapter 10. It's 10.7. And then we'll have a quiz on that. And then we'll be testing. So that's it. We'll see you all next time for section 10.7. Thanks for watching.